12.5, volume of pyramids and of cones. In this section, I want you to be able to find the volume of both pyramids and of cones. Let's start by looking at the formulas. If you remember from previous lessons, to find the volume of a prism, let's review. A prism. Remember, to find the volume of a prism is a polyhedron with two bases, and to find its volume, all we did was we found the area of the base and we multiplied it times the height. So let's look at our pyramid. In our pyramid, we only have one base. And as we move up, the volume gets smaller and smaller, so that by the time we get to the top of the pyramid, we've lost quite a bit of the volume that we would have had we had two bases. By the time we get to the top, we only have 1/3 of the volume that we would have had. So we're still going to take the area of the base and we're going to multiply it times the height, but we don't have all of that anymore. We've lost all this volume in this area. Okay. What we still have is only 1/3 of that volume. So we have 1/3 the area of the base times the height. So the volume of a pyramid is very similar to the formula for the volume of a prism, only we need to put the fraction 1/3 in front of it. 1/3 times the area of your base times your height. So you're going to have to find the area of that base. Could be a square, triangle, rectangle, whatever it might be. Find its area and multiply times your height. Alright, let's look at the cone. Cone's very similar to this. A cone also only has one base. The difference between a cone and a pyramid is a cone always has a circular base. So you're still going to find the area of that base. You're going to multiply 1/3 times the area of the base times the height, but in a cone that base is always a circle. So think about how you find the area of a circle. To find the area of a circle, it's always pi times the radius squared. So we got 1/3 times the area of the base, and then you still need to multiply times your height. So for a cone, 1/3 pi r squared times the height. So that you're doing 1/3 times the area of a circular base times the height of the cone. Notice in these formulas, height is the h, the altitude height, not the slant height like we've used for surface area, but the altitude height. Okay? So, one more time, to find the area of a cone, you need 1/3 times the area of the base times the height, the altitude height. Alright, let's look at our very first example. In this example, we're finding the volume of a pyramid. Remember, to find the volume of a pyramid, our formula is 1/3 times the area of the base times the height. The base happens to be a hexagon. Now, there's different ways that we can find the area of a hexagon. In this example, we're going to stick with what they are using. In another example, we'll see a hexagon again. We'll do it a little bit different way. This time, they want to divide the hexagon into 6 equilateral triangles. Okay? In a hexagon, okay, because it's a regular hexagon, we know all of the sides are congruent. And then when we draw the radii, okay, all of these radii in a hexagon are also congruent to those sides, so we end up with 6 equilateral triangles. We know to find the area of one equilateral triangle, we would multiply 1/4 times the square root of 3 times side squared. But we have 6 of these, so what we will do is we will multiply 6 times that formula. 6 times the 1/4 times the square root of 3 times side squared. So the only thing that we're needing to plug into our formula is how long are the sides. These sides are 4 inches long, so we will plug in 6 times the 1/4 times the square root of 3 times the 4 squared. Simplify it. We don't want to use a rounded decimal answer here, so since we're going to take this answer and put it into another formula, so we're going to leave it in its radical form. You should end up with 24 square root of 3. And you're going to take this area, this is now the area of your base, and you're going to put it into your volume formula. Okay. Now for volume, we want 1/3 times the area of the base. Well, we just found the area of the base was 24 square root of 3. And then we want to multiply it times our height. Now we're talking about the altitude height. And they've shown us that the height here is 10 inches. So we plug that into our formula. Now take a moment, plug it into your calculator. Plug in the 1/3 times the 24 square root of 3 times your height of 10. Once you've plugged this into your calculator, you should have ended up with the answer, 80 square root of 3. Okay? I prefer you don't leave it as the radical answer. Your final answer, round to 2 decimal places. So hit your S to D button, round it to 2 decimal places. You should have ended up with 138.56 cubic inches, or we could say inches cubed. As its volume, remember this is a cubic measure. All right, let's move on to our next example. All right, in example 2, we want to find the volume of a cone. Notice we have 2 different types of cones. We have a right circular cone and we have an oblique circular cone. Most of the time we would just call these a right cone and an oblique cone. Notice the difference. In the right cone, remember the vertex, the line drawn from the vertex to the base, to the center of the base, is perpendicular to the base. It stands straight up and down. Okay? In an oblique cone, that vertex is not, if we were to draw the line from the vertex to the center, it does not form a right angle, so the height has to be drawn on the outside. All right, so let's look at the first cone, the one in A. We want to find the volume. Remember the formula. For finding the volume of a cone or of a pyramid, we only need 1/3 the area of the base times the height. In a cone, since the base is a circle, we will use pi r squared for the area of the base. So we need 1/3 times that pi r squared times the height. The only things that we need to plug into this formula are what are the radius, what is the height. They've given us both of those. They've given us the radius, 9.5. They've given us the height, 16.8. Plug those numbers into your formula so that we have 1/3 times pi times the 9.5 squared times the height of 16.8. Okay, plug this into your calculator. If you have the calculator that I told you to get for this class, when you plug it in, it's probably going to leave the answer in terms of pi. Then you'll just need to hit your S to D button, turn this into the final decimal answer. Okay, around to 2 decimal places, you should end up with 1,587.76 millimeters cubed. Let's look at the oblique cone. Same formula. The volume will be equal to 1/3 times the area of the base times the height. Because our base is a circle, we're going to use pi r squared for the area of the base. So again, all we need to do is plug in what is the radius, the 4.5, and what is the height, the 12. Then plug it into your calculator. So if you know the formulas, these problems are easy. Just plug the numbers into the formula. The hard part is going to be remembering the formulas. 1/3 times the pi times 4.5, don't forget to square it, times 12. Plug it all into your calculator, round to 2 decimal places. You should end up with 254.47 feet cubed. All right, now I'd like for you to give it a try. Let's pause the video. You find the volume of the pyramid. All right, if you did this one correctly, you should have started by writing your formula. Volume is equal to 1/3 times the area of your base times your height. The base is a hexagon, so to find the area of this base, we need to use the formula 1/2 times the apothem times the perimeter. We'll need to find our apothem and find our perimeter. Since it's a hexagon and each side is 9, to get the perimeter, number of sides times length of a side. The number of sides is 6. The sides are 9 centimeters long, so our perimeter is 54. To get our apothem, just a little bit more complicated than that, we'll need to draw one side of the polygon, draw the apothem, draw the radius. They've told us that the whole side is 9, but remember the apothem bisects that, so this piece is 4.5. the short side here. Remember in a hexagon that your angle measure here is always a 30-degree angle, so we end up with a 30, 60, 90 triangle, and all we need to know is how to get from the short side to the long side. You do that by multiplying by the square root of 3. So we would say the apothem is 4.5 times the square root of 3. Now plug that into your calculator. Find the area of the base. After you plug this in your calculator, you should have found that the area of your base was 121.5 square root of 3. We're going to leave it like this because we don't want a rounded decimal answer. And that's what you should have plugged in for the area of your base down here, so that you have 1/3 times the 121.5 square root of 3. That's the area of your base. And then multiply it times your height. Your height was this 15 on the outside here. Once you plug that into your calculator, you should have ended up with 1,052.22 centimeters cubed. All right, pause the video, try the right circular cone. All right. Hopefully you've given this one a try. Remember to find your volume. You need 1/3 the area of the base. The base is always a circle, so we want pi r squared. And then multiply that times your height. All right. So we begin to plug things into the formula. You've got 1/3 times pi times the radius. You can see that the radius is 6. But then you run into a problem. What's the height? Remember, this is not the height. This is not the altitude height. This is the slant height. What you had to do was find the height. You do that by forming the right triangle. You know two sides of the right triangle, and you should have found the third. We knew the hypotenuse of the right triangle was 10. Remember, its hypotenuse squared is equal to a leg squared. You knew one leg was 6, plus the other leg, which would have been your height. You did not know. Simplify. Subtract the 36 from both sides. And you would have found that the height, when you finish it completely, was 8. Okay, so you weren't given the height. You had to find it. Then you could plug all of it into your calculator. You should have found that your volume was approximately equal to 301.59 feet cubed. All right, one more example. The last example, a little bit different. I'm going to go a different direction. Let's look at the last example. In example 3, we're going to use the volume of a cone. We're given the volume, 135 meters cubed. We're given the height, 8 meters. What we're asked to find is what is the radius of this cone. Well, we start with the volume formula. Since they've given us the volume, remember in a cone, volume is equal to 1/3 times the area of the base, and the area of the base is found by using pi r squared, area of a circle here, and then multiplying that times the height. So plug in everything you know. You know the volume. The volume is 135. You know the height. The height is 8 meters. And then begin to simplify. You can get rid of the fraction 1/3 right here by multiplying each side by 3. Multiplying by 3 will cancel out the fraction 1/3 and leave you with just the 8, the pi, and the x squared. But if whatever you do to one side, remember you have to do that to the other side. So you want to take the 135, multiply it times 3, you will get 405. Now, we want to get rid of the 8 and the pi, so we're going to divide both sides by 8 and by pi. So you're going to take the 405, and you're going to divide it by 8. And you're also going to divide it by pi. Now, you won't be done until you get rid of the square on the x, so we need to get rid of the square. To get rid of the square on the x, we need to take the square root of both sides. So we take the square root of both sides, square root of the 405 divided by 8 pi to get your final answer. You will find that x is approximately equal to 4.01. Now we were looking for the radius. That's just a linear measure, so it would just be meters, not meters cubed. The length of the radius then, this cone, the radius is 4.01 meters. All right, that's it for 12.5 notes.